I'm having difficult.
And what is the difficulty with downloading
I,
Maple?
yeah, I think the address, because of the I have to use HTTP. So I'm going to try that.
Okay. But again, you download it from CUNY. There's no charge, it's free. And you need an activation number, which is on the website, but I also put it in my email, so everybody would definitely have it.
You know what? I don't get your emails. I don't know what is going on.
Well, I send them out from Blackboard, so they probably go to your CUNY email address, whatever Blackboard has. That's where the email gets sent.
I need to reach out to somebody because this semester I haven't received any email from nobody.
Oh,
So
then you definitely check, because I send out emails very frequently.
I've never got your email, but I go to Blackboard and see it. So
And every time I post an announcement, Blackboard automatically sends an email, I think.
yeah, it doesn't send it to me. So it's not only you, all the professors I have now. So
Right. Yeah, so you should definitely check, because it's important to be able to get your CUNY email.
I get every email except the professors. So I don't know what is going on. So I'll check on them.
Yeah, okay. All right. Let's see. Number theory is in the house. Are there any number theory questions I could help you with?
Yes, Professor. Good morning. Good evening. I understand the question, the page 30, question A. I don't know if you have with you the paper.
So which section and which problem?
Page 30, question A.
Page 30. Number 8?
Yes, please.
Okay. So this is number theory. Section 1.4, number 8. And the problem is to show the following, that n be an integer at least 2, prove that n plus 1 factorial plus k is composite for all k from 2 to n plus 1. So let's just do some examples. Suppose n is equal to 2. So n plus 1 is 3. So n plus 1 factorial is 3 factorial is 6. So n plus 1 factorial plus 1. So this is n equal to k equal 2. So n plus 1 factorial plus k is 6 plus 2 is 8. And 8 is definitely a composite because 2 divides 6 and 2. If I look at n, if I let k equal 3, because when n is 2, k goes from 2 to 3. N plus 1 factorial plus 3 is 6 plus 3 is 9. This is also composites, divisible by 9. In fact, if you look at these more carefully, where I have 3 factorial plus 2, 3 factorial is 1 times 2 times 3 plus 2, and this is clearly divisible by 2. And when I have 3 factorial plus 3, 1, 2, 3 plus 3, again, this is, each of these is divisible by 3, so the sum is. So it's certainly true when n is equal to 2. But in general, if I take n plus 1 factorial, that's 1 times 2 times 3. That's all the numbers up to n plus 1 multiplied together. And if I add k, it's this plus k. But k is between 2 and n plus 1. So one of the numbers in here is k. So this number, this is the sum of these two things. This is a multiple of k. This is a multiple of k. So this number is divisible by k, which means it's composite. It's not prime. Right? So that's the argument.
Thank you, Professor.
Okay. Other questions from any of my classes?
Yeah, for 348, the homework, I think number 9, the 1.9. (1.9).
Okay, just 1 second. So what is the number? 3.1-9?
Yes.
Okay. So this is a typical linear programming problem. And what you have to do is read the text and interpret it and translate it into mathematics, right? You have to translate the discussion of the problem into mathematics. So in this case, you have a company that has 3 employees and makes 2 kinds of windows, a wood window and an aluminum window. And you make $300 for each wood window that you sell and $150 from each aluminum window. And there's some information about what the 3 workers can do. One can make wood frames and 6 a day. One can make aluminum frames and 4 a day. One can cut the glass, and he can make 48 square feet of glass per day. And it tells you how much glass each of the 2 different windows uses. And what you want to do is determine how many windows of each type to produce each day to maximize the profit. Right? I mean, do you have any questions about what it is that the problem is asking?
No, I just wanted to know how to formulate it. So as you said, I have to translate it into mathematics and solve it, right?
Right. So for example, in this problem, what is it that you want to maximize? So in Math 348, problem 3.1-9, you're going to make 2 types of windows. Suppose we let x1 be the number of wood framed windows, and x2 be the number of aluminum framed windows. So the objective function, what you want to maximize, Z, it's your profit. And for every wood frame window you make, you get $300. So if you make X1 wood frame windows, this is 300 X1. For every aluminum frame window you make, you earn $150. So 150 X2. So this is the objective function, and you want to maximize it subject to the constraints. Okay. So what are the constraints? You want to know how many windows to produce each day? Well, Doug he can only make at most 6 wood frames a day. So X1 can't be any bigger than 6. Linda makes the aluminum frames, and she can't make more than 4 a day. So X2 is at most 4. And Bob cuts the glass, and for every wood frame window, he needs 6 square feet of glass. So if you make X1 wood frame windows, it's going to need 6X1 square feet of glass. An aluminum window uses 8 square feet. So if you make X2 aluminum windows, that's going to take 8 square feet of glass. So if you make X1 windows that are wood and X2 windows that are glass, this is how much glass you're going to need per day. And you're told that's at most 48. And then you also have the non-negativity conditions, because you don't make a negative number of windows. X1 is at least 0 and X2 is at least 0. So these are the constraints on the problem. And if you want to try to solve it graphically, with the ruler and graph paper, you can do it better, but X1, so this is the X1 axis. X1 is at most 6, so you're somewhere in this strip. And X2 is at most 4, so you're in this rectangle. But then you also have this condition. So for example, when X1 is 0, X2 is 6, this is a straight line. When X2 is 0, X1 is 8. So you're also under this line. So your feasible region is this shape. And then for all the points in that region, you have to find the point or points where this objective function is as large as possible. That's setting up the problem, and that's what you have to do.
Okay, thank you, Professor.
Yeah.
Professor,
Yes.
you don't have to work out this problem, but I just have a question. So this is problem number 30.
Okay.
This is this is from page 21, problem 11.
Let me take a look.
So,
Page 21. number
21.
11. Yeah.
Yes. I'm sorry, 23, 11.
Yep. Okay.
Okay, so the problem is asking to compute P seats over Q seats, right? But inside the brackets, there are 7 digits. So we need to compute from I mean, the 6 first digits, or we need to do all of them?
Correct.
All of them, or only the 6, the first 6?
Sorry, what? I didn't understand what you said.
So it asked me, right, to compute P6 over Q6, right?
Correct.
But inside of the brackets, there are 7 digits. So we have 1, 2, 2, 2, 2, 2. So there's 7.
Right.
So in order to compute the simple continuous fraction, do we need to work out the 7 digits or only the first 6?
No, you have to work out. So the whole thing. So P6 over Q6. So if you write a continued fraction, A0, A1, A2, up to A sub n, right? So
I got it. So one will be A0, right? And then the last one is gonna
Oh.
be A6.
P0 over Q0 would be A0. P1 over Q1 would be A0 plus 1 over A1, and so on.
Okay, got it.
Okay.
I have another question. Can you please go over, this is section 1.4, problem 6.
Problem, sorry, which problem?
Problem 6 from section 1.4. It can be 6 or 7. They're pretty similar.
Okay, so this is number theory, section 1.4, number 6. So we look at the 3 numbers, n plus 2, and n plus 4. So if n is equal to 3,
3.
these numbers are 3, 5, and 7, and they're all prime. Of course, if you take n equal to 4, you have 4, 6, 8, they're all even. And in fact, if n is even, they're all going to be even. So none of them is going to be a prime. So you only have to look at odd numbers. So say you take n equal 5, then you get 5, 7, and 9. But 9's not a prime. If you take n equals 7, you get 7, 9, 11. 9's not a prime. If you take n equal 9, you get 9, 11, 13. 9's not a prime. If you take n equal to 11, you get 11, 13, and 15. 15's not a prime. So when you have to prove that you're never going to get 3 primes except for n equal 3. So a reason could be the following, like suppose you take n and divide it by 6, 6q plus r. And if n is odd, r is 1, 2, or 3. Is 1, 3, or 5. That's just division. If you take a number and divide it by 6, and its n is odd, then the remainder has to be odd. Okay, is that true? So let's look at the 3 cases, like r equal 1. So n is 6q plus 1, but then n plus 2 is 6q plus 3 is 3 times 2q plus 1. This is composite. So if r is 1, n plus 2 is composite. If r is 3, then n is 6q plus 3, but this is already 3 times 2q plus 1. So it's divisible by 3, so it's composite. If r equals 5, n is 6q plus 5, n plus 2 is 6q plus 7, that might be okay, but n plus 4 is 6q plus 9, which is 3 times 2q plus 3, which is divisible by 3. So it's composite. So in all three cases, you get a composite number.
Mhm. This is by using division algorithm, right?
I'm using the division algorithm, exactly.
Mhm.
Other questions?
Professor, I see that you are recording. Are we going to get the recordings or no?
Sorry, am I going to record this?
I saw that you are recording it, so I want
Yes.
to know if you're going to share with us.
Yeah, I will save it and post it on the YouTube website.
Awesome. Also, Professor, for the Maple, are you going to set a time for us to teach us how to use it?
Oh, yeah, I'm going to have a couple of classes on how to use Maple, or at least
Awesome.
the parts of Maple that we need for the class. Right?
Sounds good.
So like some people use Maple for Math 155 or Math 156 for calculus, but we're not going to do calculus in Maple, so we don't need to learn those. I mean, it's very nice to know, but we don't need that for this course.
Yeah. I used GeoGebra for 155, so
Right. Yeah, you can't do a lot of this in GeoGebra.
okay.
Hi, Professor.
Hello, yes.
Hi. So I know Joyce already asked you about like working through a problem for Mat 348. I'm not sure if she covered asking you for just to formulating the linear programming model itself. Did you cover that as well? If you did, it's fine. I'll just watch the video. when you upload it.
Let's see. Let me pull that back up again.
Sure. Thank you.
That was how I set up the linear programming problem.
Yeah, my thing is getting like the X1, you know, the whole, just the formulation of the actual linear programming model. How do you get that part?
Oh, well, so that is, I don't know. I mean, how did I know what to do?
No, I know what, once I have it, I know what to do, but it's like getting like the inequalities, like how do you get it from the problem itself? Like how
These
do
three
you put it
inequalities?
together? Yes, yes.
Oh, okay. So it really is just a matter of reading the problem very carefully, maybe many times, to understand what it's saying. So for example, in this problem, it says the worker Doug makes the wood frames and can make 6 per day. So if you're going to order X1 wood framed windows, you can't have per day, you can't have more than 6. So X1 is
Okay.
at most 6. And Linda can make 4 aluminum frames a day. So the number of frames you ask her to make, it doesn't have to be 4, but it certainly is less than or equal to 4, because that's the maximum she can do. And if you look at how much glass each window requires, the wood windows require 6 square feet per window. So if you make X1 windows, you're going to use 6 X1 square feet of glass. The aluminum windows use 8 square feet of glass per window. So if you make X2, that's going to require 8 times X2 square feet of glass. So the total, the sum is how much glass you're going to use altogether, but you're told you can't use more than 48 square feet of glass a day. So this has to be at most 48. But it really comes from just reading the problem, maybe many times, to learn what to do. And a lot of this just comes from practice and experience and just working at it for a while.
Okay. Because you make it seem so easy, but then when I look at the problem, it's like all jumbled together.
Exactly. That's
But,
the thing. That's the difficulty. So it's like with a lot of things, when you understand what to do, it's easy. but getting to the point where you understand what to do takes, some work. Right?
Okay,
That's,
Thank
but
you.
that's just, experience and working at it.
okay, I'll keep practicing. Thank you.
Okay.
Okay, I'm gonna leave now, Professor. Have a good night and thank you so much.
Okay, thank you.
Welcome.
Other questions? Anyone?
Thank you,
Thank you,
Professor.
Professor.
Okay, thank you for coming. I'm also going to have an hour on Friday, probably in the afternoon, if you have any more questions you want to ask. And I'll send
Professor,
an
before
email
we
out
leave-
about that tomorrow.
I'm sorry, are we done with office hours?
Sorry?
Are we done with office hours? I have another question.
Oh, no, if you have a question, go ahead.
Okay, this is 30 number, so this is section 1.4, problem 24.
Let me take a look.
Oh, this is related to the least common multiple.
I'm sorry, what did you ask?
Oh, no, I see the bracket, so it comes to my mind that this is related to the least common multiple, right?
Correct.
The problem 24.
Yes. So I think I did this in the lecture this morning, but I'll do it again.
Yeah, it comes to my mind now that we did something similar today. I just didn't realize that it was related to that.
Right, okay.
But it's okay. I can go over the video again, the recordings, and then on Friday, if I have extra question, I can ask you.
All right, that's fine.
Thank you, Professor.
Okay, thank you. Bye.
Good night.
Good night. Bye.